hoping that you didn't break the forbidden rule and say, oh, I'm going to do 3x squared and negative 2 squared. I'm just going to square each term. We're all past that point, I'm hoping. Are we past that point?
Yeah.
Oh, good, good. Okay, so how do I need to rewrite this?
You're going to go 3x minus 2 parentheses and another parentheses 3x minus 2, and you're going to distribute.
I love how Chanel says distribute. She uses the correct terminology in math words. She says, now we're going to distribute. So guys, I'm going to start with 3x and distribute it through to each term over here. 3x times 3x, careful.
9x squared.
Good, Chanel. 9x squared. Now remember what we're doing here. We're multiplying, right? So 3 times 3 is 9, and I like how Chanel said x times x is x squared. On the quiz, guess what? Most of you forgot the x squared part. How many of you on accident today again forgot the square? Okay. So be careful, right? Okay, let's keep going. 3x times negative 2.
6x. Negative 6x.
Good. Negative 6x. And now I have negative 2 times 3x.
Negative 6x.
Negative 6x's. And then negative 2 times negative 2.
Positive 4.
Positive 4. Okay, guys, you have to get that distributing down. We're testing on this on Monday. It would be a really tragic thing to miss this one on the test because I think you know how to do it. You're just kind of being maybe a little bit careless, maybe, or maybe just making little errors. Okay, let's combine all like terms. We have a 9x squared, no other x squareds, and then I have negative 6x plus negative 6x is how many x's do we have? Negative 12x's, good. Does everybody understand how negative 6x plus negative 6 more x's is negative 12x's?
Yes.
Okay, and then we have our plus 4. How many of you got it 100% correct? Raise your hand. Good. Good. That's okay. So Chanel, you screwed up, but you see it now, right? So we're remembering now, and then when that test rolls around.
After some period of time, you have to scribe it like,
Oh yeah. Good. It's good that you see it. I just give you as many points as I think you deserve.
So 20,000 for me every time. So.
Okay. Any questions on this? What?
You got points on it.
If you get what? Wrong. Yes, I do. But I'm pretty generous with my point giving. Okay, here we go. So today we're learning more about rigid transformations. We have heard that word before. Remember, like almost the first lesson, almost on one of the first days of school, we talked about rigid transformations in general, but we didn't apply them. So today we're going to apply it. I think you're going to like this lesson. It's kind of a breath of fresh air because it's not super hard math. So but we have to know what we're doing for sure. So first of all, rigid transformation just means you're performing either a dilation on an object, a rotation on an object, a translation on an object, or a reflection.
What's a dilation?
That's what we'll talk about. We'll go through each of these things and practice them. So it's whether you either get it larger or smaller. Okay, so first of all, before we begin, we'll talk about these individually. We'll go through and talk about what these are once again, but I just need you to understand something before we get started. You're going to have an object on an XY chart, just like this. They're going to name the vertices such as A, B, C. Does everybody understand that much?
Yeah.
Now, after we perform a dilation, a rotation, a translation, or reflection, it's going to look different. And they specify that you've done something to the object by putting this little tick mark above the letters. So you'll just know that it started here and then ends here because the tick marks specify this is after I've performed one of these rigid transformations. So that's all I need you to get out of this slide. Now you could do more than one of these things. If you do this and then you do something else, it'll just be A double tick, B double tick, C double tick. So do you get how the ticks work? That's all we need to get out of this slide. Okay, awesome. So first of all, we're going to talk about rotations. We're going to take an object and rotate it. Now we can rotate things clockwise, so how you read a clock would be around clockwise, and then also counterclockwise. So notice counterclockwise goes against what you would read the clock. Does everybody understand what clockwise is versus counterclockwise? Okay, awesome. Now, in this class, in secondary 2 regular, we stick with the pretty much two basic rotations. We're going to be rotating objects 90 degrees, and we're going to be rotating objects 180 degrees. Now, if you think about 180 degrees, we know that's halfway around a circle, right? So the rotating 180 degrees will be taking something and flipping it a full half circle. Does that make sense on 180 degrees? Okay, awesome. Now in secondary 2 honors and stuff, they do like 270-degree rotations. We can do different types of degrees, but in here we're just gonna stick with these. Okay, now you're gonna see the words. I just need to explain this. You're gonna see the words. Now my little thing here, my recorder's covering it up, but you're gonna see the words about the origin. We're gonna be rotating about the origin, meaning the middle of the graph. Well, don't let that throw you off too much. The way I'm teaching you is how we rotate things around the origin. So when you see that, don't say, what does that mean? I'm teaching you how to do it about the origin. So you'll be good. Yes? Yeah, that. So you're saying 270 clockwise would be 90-degree counterclockwise? I could see it for some objects. Others, I feel like it'd be off a little, but it might be on. I'd have to think more about that. Yeah, I'd have to think more about that. But that could actually be true for a lot of objects. So, yeah. Okay, let's just practice this. Now, rotations are the hardest ones of our rigid transformations, but since we have this patty paper on your desk, patty paper is just see-through paper. It makes it really easy. On the test, I'll give you patty paper. On the end of level test, I'll have patty paper for you. So actually, these will be one of the easiest because you'll use your patty paper, but we have to know how to do it. So looking at this, first of all, we have this triangle, this shape A, B, C, and we're going to rotate the object 90 degrees clockwise about the origin. And then we're going to stay where the new points fall and then draw it in. So first of all, this is how you'll do it. I'm gonna show you how to use your patty paper. Okay? So you'll do it just as I am with this. You're gonna put your patty paper over your graph, your see-through paper. Now this is so important, so please listen to this. The first thing you must do is draw in X and Y, that little X right there. Because once we rotate this, we need to keep it lined up. Does everybody see what I did there? Okay, now you'll draw in the vertex, meaning the endpoints of your picture. So that's A, that's B, and that's C. Okay, questions up so far? Now I'm going to take this and I'm going to rotate it 90 degrees clockwise. Clockwise will be this way, right? So I'm going to take and flip it once around. That's 90 degrees. Now I line it back up. Very important, you line it back up. Now I see exactly where C falls, where B falls, and A falls. Does everybody see it? So let's quickly write down the points, because notice I can't draw on, because my patty paper will be covering the picture, so I'm going to write it on the patty paper and then use it. So A is at what point? A is at what point? -1, 2, and? -2 and 0. Good. B is at what coordinates? -2 and -4. And C, I'm lining it up. C is at +1 down 1 down -2. Good. Okay. So now I take off my patty paper. Notice the picture isn't there, so we have to now re-put it in, redraw it in. Oh yeah, it takes forever to get this reconnected real quick. Okay. All right. So I'm going to hurry and plot down those points. So we have, and I'm going to do it in green, and I'm going to change to not this calligraphic pen. There we go. Okay, so we have points A0 at -2, 0. So -2, 0. That was A0 means a tick. A0 means a tick. So I never said that. And then we have point B at -2, -4. So -2, -4. That was B0. And then I have point C at 1, -2. So over 1, -2. That's not right. I was not thinking. I was thinking ahead. Negative 2. Sorry, over 1, negative 2. Over 1, negative 2. Okay. So that's C naught. Now you can draw it in your picture. Did everybody see how I use my patty paper?
Yes.
Okay. I'm going to do one more, and then I'm going to let you work. Now, I am requiring you to label these points. Okay, once again, last one, then I'm going to let you work. I'm going to do the same thing. So it says rotate the object 90 degrees. Now this time counterclockwise. Most important thing is to put your patty paper up against it so you can see through it. Most important thing is to draw that line so you can line it back up. This is point B, point C, vertex C, vertex A, and vertex D. Now you have to rotate it the correct way. If you go clockwise and it was supposed to be counterclockwise, you won't get the same answer. So I'm rotating this 90 degrees counterclockwise, so that would be around this way. Now I have to line back up my X. I'm on it like blue on it. Okay, yeah. So what's my points at? Really quick. D is at what point?
D is at, let me see.
Sorry, I'm moving it, aren't I?
It's at negative 1.
Negative 1.
Negative 2.
Negative 2. Point C is on at?
It is at, let me find it real quick. Negative 5.
Negative 2. Good. Negative 5, negative 2. And A is at?
It's at negative 1,
Mhm.
negative 6.
Negative 1, negative 6. And B is at? Negative 5.
Negative 6.
Okay, so now I would go through and draw that in. I'll do that while I let you begin. Do you have any questions on how that works? Now, one more thing before I set you free, and then let's see if this answers your question, and then I'll let you ask it out loud. If we're rotating something 180 degrees, that's 90, 180, yeah? Okay. Now, is that any different than if I went 90, 180, or is it the exact same? It's the exact same when you're going halfway around a circle. So if you can rotate it, if you're going 180 degrees, it doesn't matter if you go clockwise or counterclockwise. Because a half a circle is a half a circle no matter which way you go. Does that make sense? Okay, so I'm going to finish drawing this up here just for you guys, and then you guys can work on, yes, Tyler.
So for 90 degrees, can you just make all the coordinates negative and make that was 5 here?
No, X and Y switch, and then it's negative. One of them will be negative. It'll be different. That's why we use patty paper. And that's the thing is with rotations, that they're really the only ones, well, I can't say only ones. They're really hard to just see by the human eye. So that's why we use patty paper. I taught it differently last year by teaching a rule, but that you have to memorize that. So if we have patty paper, then we can always do it right. So, but yeah, that's why rotations are hard. You can't just see it. So yeah, ready, set, go. So ready, set. Yes. Do problems 1 through 3. So these are what we're on now. 1 through 3. Okay, so now we're going to talk about reflections. There's lots of reflections we need to talk about, okay?
Wait, why did you write it so weird?
It's in a calligraphic pen, so just
I like it.
thanks. It does look great. Okay. So the first reflection we can do is across the x-axis. Now this is really important you pay attention to. So across the x-axis, the first thing I'll do is find my x-axis and make sure I'm reflecting across the correct thing. So this is my x-axis. Does everybody know that this is the x-axis right here? Okay. So guys, this is kind of a good way of thinking of it. A reflection is like taking it and stamping it across whatever line you're reflecting it on. So do you see how if I have a smiley face and stamped it? Yeah, it's a mirror image.
Okay, this has to do with math. I promise.
I know, okay.
Okay, so we were going to the A games, and my friend had money, so we just put it.
All right, moving on. Now we can reflect things across the y-axis. So this is the y-axis right here. I draw my line. Make sure you reflect things across the correct thing. So this is my y-axis. If I took this and stamped it over across this side, then it makes a mirror image. Okay? These are the two harder reflections. These are the two harder reflections, so we need to understand these. You can also reflect across the y is equal to x axis. Now, people say to me, well, I don't know what y equals x means, so let me tell you. Think about a line, guys. Lines have the form y is equal to mx plus b. Is that true?
Yeah.
Now, m is the slope, and b is the y-intercept, where it's crossing the y-axis. Does everybody remember that? Okay, so looking at y is equal to x, what's my slope? What's the number in front of x? It's not 0.
1.
1. So my slope is positive 1. And then what's my y-intercept on y is equal to x? 0. It's like having a plus 0 out here. So my y-intercept is 0. So look at the blue line. I graphed y is equal to x by it crosses at 0 because that's the y-intercept, right?
Yes.
And then I go up 1 over 1, 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 up 1 over 1. And I get my line, right?
Yeah.
So if we take this and reflect it over the y is equal to x axis, it's taking it and stamping it across that line, and that's our mirror image. Now look how cool this is. You don't have to use your patty paper for this, so it's kind of nice. Look at this. This is exactly equidistant across the y is equal to x axis. So this point is stamped to here.
So instead of it being on the y-axis, it's going to be on the x-axis.
Right. It's going to be exactly, but do you see how it's equidistant here to here?
Yeah.
Okay, awesome. That's what I wanted to get at. And here, it's equidistant from here to here. It stamps to there. Now look, from up here to down here, it's equidistant if I stamped it. Does that kind of help? Okay. So now looking at this, we can also, we can reflect across the y is equal to negative x-axis. This just means negative 1 slope. So we would cross at 0, 0, and then go down 1 over 1, down 1 over 1. Does everybody see how the purple line is negative x?
Yeah.
The line negative x. Okay, yes.
So all the time when it says y equals x or y equals negative x, it's always going to be that line.
Yes. Yep, it'll always be that line. Good question. But if it says the x-axis, you use the x-axis. If it says the y-axis, you use the y-axis. Does that make sense?
Yeah. So if it says x equals y, you go this way.
No, if it says x is equal to y, and it'll always say y is equal to x, that would be the line.
So either way,
It's just a straight line. Right.
Okay.
Yeah, good question. All right, so I'm going to show you how to do this one without, I hate patty paper, so I just do it how I just showed you. So you have to pay close attention. So I'm going to start with A. I'm reflecting it over the x-axis. Very important. So let me show you. I'm drawing my x-axis so I know I'm reflecting, stamping over that line. Okay, now this is A. It was 1 unit up, right?
Yeah.
So I'm going to go to my x-axis and go 1 unit down. That's A naught. This is B, and right up here, it was 1 unit up. Is that true?
Yes.
So I'm going to go 1 unit down. There's B naught across that line. C is up here, so I need to go to the x-axis and figure how far up to get to C. So up 1, 2, 3, 4, 5, 6. So I go back down to here and count down 1, 2, 3, 4, 5, 6. And that's C naught. So then I can draw in that stamp, the perfect stamp there. Do you have questions? Ashton, I need you to sit, not moving in circles, laughing at your friend. I'll kick you both out. I'm so sick and tired of you both, really, to be honest. Everybody else is too, because I had people comment in the bell quiz that they're sick of people acting crazy in class, and I'll show you the bell quiz, and you won't know who it is because I've X'd it out, the person, but I promise I'm not the only one sick of how you act. Both of you. Okay? Yes, Chanel.
Can you just go back to the table? Because you sidetracked them.
Okay, just don't distract people. You can't argue. You're distracting people. It's that simple. Do you have questions on this one? One more example, and then I'm going to set you free to work. Okay, I'm going to change this one. It says reflected over the y is equal to negative x. I'm just going to do y is equal to x-axis. Y is equal to x is different than the x or the y-axis. the line y is equal to x. So that's this line. I have to draw it perfectly though. Notice I have a perfect slope of 1 as I draw this. Okay. So now I'm going to go through and say, okay, now this one's trickier, so watch with me. We need to stamp it across that line up down here, right? So I'm going to be careful as I count because we're going to be going in diagonal. So that's 1 unit, 2 units, 3 and a half. So I got to go 3 and a half now. A half, 1, 2, and 3. That's A naught. Now I'm going to do C naught very carefully. 1 unit, 2 units, 3 units, 4 and a half. So 4 and a half more. A half, 1, 2, 3, and 4. That's C naught. And then B naught. Okay, counting carefully. 1, 2, 3, 4, 5, 6 and a half. A half, 1, 2, 3, 4, 5, and 6. And there's B naught. Now look, makes sense. If I take it and stamp it, ding ding, it's gonna fall in the right place. That's Hammy Sammy. Okay, ready? Finish up the word. Do problems 4 through 6. Ready, set, go. So you can finish this worksheet up. So this is the last time I'll bother you, but you do need to watch. You really do. So now we're going to talk about dilations. Dilations can be tricky because we'll get to why in just a second, but you need to understand something. A dilation, it tends to feel like it's only getting bigger. Dilation is getting bigger, but also taking an object and shrinking it down is considered a dilation. So every year it never fails that I have a student say, well, that wasn't dilated, it got smaller. But we can have dilations that get smaller. Does that make sense? So you can have a dilation that takes an object and makes it bigger, or you can have a dilation that makes the object smaller. Either way. You do the same thing either way though. Okay, so what you're going to do, you have to take every single one of your vertexes. You're going to figure out their xy points. So I have a bunch of xy points at the vertex of my shape. And then you're going to multiply by the factor. So you'll multiply both x and y by the factor that you're either getting it bigger with or getting it smaller with. And then once you've done that, then you can go ahead and graph it. So let me show you by example. It'll make more sense when you see it. Okay, so now do not make this error, guys. Let me just show you what students like to do. Now, if we read this one, it says dilate the object by 2 about the origin. I have students say I'm going to blow them up by 2, so it's going to be twice as big. They think that you can do that, but you can't. That's not true. Because we're dilating it about the origin, not about itself, it's not going to be that. It's not going to just blow up. So you've got to do it the way I just told you. So first of all, let's list out what are my points of A, B, and C. So what is my A at?
1, 2.
Okay, 1, 2, B is at what? 3, 2. C is at
0, 1.
1, 0. D is at 3, 0. Okay, so we're dilating by 2, so we're going to take those points and multiply.
It's 0, not 2.
You put 3, 2.
Thank you.
Has it been a long day?
I'm just thinking in head, so I can't think and draw at the same time usually. Because we are going to dilate that by 2, so as I said 2, I wrote 2. So we're going to dilate that by 2, dilate that by 2, dilate that by 2.
So it's going to be 3, 4, that's actually really 5, 4.
So let's go ahead and multiply both x and y by 2. So what are we going to have? 2, comma 4. We're going to have 6, comma 4, and 2, 0.
So all you're doing is spinning to your computing.
Yes, we're just multiplying each thing by 2. Yep, so 6, 0.
How that times there, then all you can do is do.
We're multiplying by 2. I'm just writing out my work so you know that I'm multiplying by 2. So now I'm going to go through and draw those points. So A naught is at over 2 up 1, 2, 3, 4. That's A naught. And B naught is at 6, 4. So I'm going over 6 up 4. C naught is at 2 up 0 over 1, 2 up 0. And then C naught, D naught is at 3, 0 over 6, 0. Over 6 up 0.
Up 0.
Up 0.
Up 1.
Up 0.
Up 0. I see what you did wrong. I do that all the time.
Yep, thank you, Tyler. And then we draw that in, and it is dilated by 2. Now notice it didn't dilate about itself.
Yeah.
It dilated about the origin. Does that make sense?
Yes.
So on a test, I might say to you, what are the vertices? And I would have wanted this answer. So you have to know how to do it by hand and by picture. Does that make sense? Okay, I'm not going to do any more of those if you understand how to do that. Okay, last one. Oh, wait, no, I have to do this one because I'll have students ask if I don't, I promise. So quickly, let's go ahead and dilate this by 0.5. So really quick, A is at what point? 6, 4. B is at 4, 9. And C is at 8, 9. Okay, so now once again we're dilating by 0.5 this time. So we're going to multiply each point by 0.5.
So, like, what the number is, you type it like that?
Yes. Yep, you just times it by that. So our new point is going to be, what's 6 times 0.5? That's the same thing, guys, as 6 divided by 2. But let's say you didn't know that. You type it into your calculator. What do we get? 3. And then what's 4 times 0.5?
2.
And then 4
2.
and 9.
3. 4.5.
4.5. 8 is,
4.
and then 4.5. Okay. Look how I graph decimals, guys. So I go over 3 up 2. And then I'm going to go, and that's A naught. And then I'm going to go over 2. Up 1, 2, 3, 4 and a half. So I'm going up a half. And then I'm going over 4, up 4 and a half. Does everybody see I went up a half?
Yes.
So there's, what was that?
So when
It did shrink by half. Yep. Yes.
it's under 1, it's a strength when it's above 1 up here.
Good point. Brian just said if it's above 1, it will be getting bigger. If it's below 1, it will be getting smaller. Yeah.
Will there ever be a question where it's to dilate with only 1?
No. I mean, if you did see that, then you'd know that it's just going to map back onto itself. Yeah. Good question. Okay. So just one transformation, and then I'm going to let you work. So it says shift the object 3 units right and 2 units up. These ones are the easiest because you can just start at a point, so A, and move it piece by piece. So I'm going to move A first. So I'm going 3 units right, 1, 2, 3, and up 2 units, so up 1, 2. And then I'm going to go with B next. So right, 1, 2, 3, up 1, 2. There's B. That's where B moved. C. Right, 1, 2, 3, up 1, 2. And now I have my new move. So translating is the easiest. Does everybody get that? Now I'm going to let you just work the rest of the time as long as you'll look at this with me really quick. Just so you know this notation. This is just another way of writing a transformation. It's saying move X on the X-axis, so left and right, we're going to move down 3. And in this one, we happen to also, oh, sorry, not down 3. Erase, ignore that, ignore what I just said. With X, X is left and right, right? So this is going to move us left 3. Now, I'm going to change this so you can see how this works really quick. I'm going to change the problem to say y plus 2. So, oh no! No! Okay. There we go. Okay. What if I have y plus 2? There we go. If we had that, then it would be a transformation of left 3 and up 2. Does everybody see how that would work in that notation? Yes?
Yes.
Okay, good. Okay, good. So if you know that, then you're all good. Now make sure you're just careful with these, okay? All right. Finish her up. Finish up the worksheet. Ready, set, go. Make sure you check them when you're done, please.